Welcome back to Cloud Computing and Big Data. Today we have our lecture 8, Infrastructure as a Service, and the second part. In the first part, basically, we discussed the Infrastructure as a Service model in contrast with the Platform as a Service model, in contrast also with the Software as a Service model, which are sort of different layers where you can categorize some of the services that are available in cloud computing. And we have learned that Infrastructure as a Service is basically the topic where you talk about bare metal resources, and of course also in combination with virtualization. So you talk usually about a setup of virtualized resources, because we learned in lecture 4 already that virtualization is a key to really leverage, for instance, with virtualized clusters, much more the power of this physical infrastructure underneath before it stands idle, and have economics of scale then for different users that are sharing basically then the access to this physical resources. So, and you can go on different topics that we have discussed, which are key to infrastructure as a service. Another one that is really a kind of unique selling proposition, perhaps for Iceland, perhaps alongside also the Nordic countries in general, is then basically the idea of having green energy, renewable resources, hydropower, geothermal power, and of course the ambient air cooling, because in generally it's already quite cold. And if you remember in one of the lectures before, we talked about the data center costs are mostly really having the cooling as one of the biggest factors, right? So at least 1/3 or so, as a rule of thumb, you can say goes usually into cooling. And in Iceland, we have the situation, and of course in the north of Finland, where Lumi, the supercomputing infrastructure is existing, these are just beautiful spots where ambient air cooling already helps to reduce costs for this. And then, of course, you have also the idea here in Iceland, particularly of having renewable energy sources instead of using, for instance, coal, which enhances, of course, the CO2 footprint, if you want, of your computing cycles day by day, hour by hour. And this is something which becomes actually much more important. So green energy, the Green Deal, CO2 reduction, the carbon footprint are all topics where infrastructure as a service is really in high discussions these days, where you put your infrastructure. Then the development of the services on top could be in different fields. So if you think about that the infrastructure, for instance, of this Lumi supercomputer is in the north in Kajaani in Finland, but the whole development around it, the services, the software is then done in Helsinki. So then you're a bit more location independent, of course, the higher you get in the levels of the services. But the physical infrastructure, of course, from IAAS is something where you have to think about that this takes electricity. It takes also considerations that we have seen in the video about Iceland. Do you have a reliable country, a secure country, or do you put it somewhere where you don't know what's happening? Ironically, if you want, we have, of course, volcanoes, we have earthquakes, but still Iceland is considered being one of the most safest ones, especially if you place a data center on locations which usually don't really are affected, with the volcanic activities. Still, a very interesting topic, a very hot topic, if you want, especially in the energy crisis that is happening right now while we have this lecture. And of course, will in generally play a big role in the future of reducing the CO2 footprint when you think about all the centers, data centers around the world, which are not in a cold climate. And of course, data centers by Iceland promote this idea, and many others around the world as well that are mostly in the Nordic countries, for instance. But let us come back to some other provider here in Iceland. here also goes a message. I'm not paid by Verne Global, but it's a good example how, of course, data centers team up with a vendor, which is NVIDIA here in this case, to have really an interesting enterprise solution hosted basically, of course, in Iceland, because it's also good for the vendor to have the marketing of saying, well, we can basically compute all this deep learning in a 100% renewable environment. And for this, you need infrastructure. As I was alluding to, there's basically this Verne Global data center close to Keflavik, which is basically interesting also to go to if you have interest. But basically, we see the idea of teaming up with a vendor to have then really enterprise solutions of this NVIDIA is something which is also, let's say, used quite intensively, not only in Verne Global, also, of course, in many other vendors. This was just a good video here, I think, which is very interesting to show you again the benefits of Iceland in combination, or also where vendors take part of it. Hence, you also don't need to go to Amazon all the time. It really depends. If you have very specialized needs in Amazon that you need, let's say very specific services, talking especially maybe on platform as a service level, if you're just interested in normal infrastructure, chances are that you're actually very nicely served already by Iceland. Also because you get here very good contracts. If you've seen 15 plus years for basically as a data center, getting energy and so on. So this is really good contracts. And then on top of it, you have this interesting cooling, the renewable energy, and the saving. I mean, the safest place in the world is also, of course, taking account not only earthquakes or volcanoes, which you would say is ironically for the safest place, but also political stability and many other factors. Hence, why also Iceland is basically considered to be the global player there. And you can go on and go on. Of course, we should say generally Iceland shares this unique selling proposition, of course, with Finland, with Sweden. You will see Advania data centers are not only here in Iceland, they're also in the north. And another example of these clusters, which you see here, is then the cluster from Advania to show a little bit, let's say, variety, where you have infrastructure as a service clusters with the so-called HPC flow. So you see basically their market niches that hyperscalers perhaps here and there are, of course, could serve, but chances are that you maybe get better contracts if you basically go to your countries in the north, especially, and talk to, you know, these different providers or talk to data centers by Iceland, for example. So, and here goes, of course, the Icelandic fraction of the course. I'm sorry for this, but you are basically listening to an Icelandic lecture here in the University of Iceland. So hence we take this topic a little bit more important, of course, than perhaps in other countries. So we talked about computing a lot, and I think it's important also to understand that the cloud obviously has also big data needs. And we have the different services. Again, obviously, Amazon is a very strong provider of very different services. One of the different factors you have seen in the video from the first part is what happens if the data center goes down, right? So durability and security not being hacked and so on. These are all also elements which on top of scalability that are always rise, right, already, or that are alluded to with scaling up, scaling down, on demand. You have to also see these factors. So the chances are not very high that all the Amazon Web Services data centers will collapse at one point in time. So I think this would be then a world problem, I think. So in this sense, you would have something which you say is perhaps never 100%, but you see that basically using these services, usually with your data, leads up to 99.9% of, you know, availability of the data, durability, that this is not lost. Think about your own one that you have maybe in the cellar somewhere, the infrastructure, which gets overheated, or basically there's some water damage, some flooding, and suddenly the whole server is just destroyed, and you basically don't have, of course, backup somewhere else, maybe, because then you would perhaps already use a cloud. Hence, storage in the cloud is a hot topic as well. And not only for scalability, instead, it's really something for, as I said, durability, security, migration from point A to B, access via APIs, which is also these days a very important topic for developers. You see here a little bit the idea of the bucket store. We had already in earlier lectures, so just key value pairs make it relatively easy to access the S3 service with these different interfaces. So REST is very popular. REST APIs, we look into this a little bit, but web services on SOAP have been also very popular the last 20 years, really, with you basically XML message exchanges over the internet. Now REST uses a little bit more of HTTP to achieve similar aspects, basically, that you have in the SOAP. And this is something where basically the S3 service is very strong. Some people even say that S3 is more or less a sort of de facto standard in the cloud. Here, as a professor, I would be a bit careful to say that, but you can imagine that many use the S3 service, and with this, the interface to basically have data accessible via S3 is, of course, also a hot topic. Now, basically, examples how you can make use of such instances was also in the video a little bit on the high level. Of course, websites, right, are beautiful here in this regard, especially if you think about there's no usually secure data, there's no top secret data on your website, otherwise you wouldn't put it on your website, hence public data. So a beautiful idea how to do this. You have several, of course, services already around this. You see here Amazon CloudFront and Root are two helper services that you can combine with this bucket store in order then to create very easily basically a domain, and then basically have a very flexible service here. If you think about the upload and download service that you said, perhaps via website, swiping the credit card for getting some Icelandic pictures here from the nature, waterfalls. Maybe if you want to extend to videos, then you basically just have a little bit more of the architecture here extended, right? So the infrastructure is scalable, as we know. And the beauty is it's already very durable, it's backup. So basically chances to lose your images from Iceland or your videos from Iceland are basically relatively low. Of course, you have to think about the payment, right? So don't forget that. In order to get this high availability and something like this, we definitely have to swipe the credit card again. So there's a web console where you can upload and download. I was demonstrating this when we basically looking a little bit into Hadoop and the outcome that we had out of Hadoop with the different word counts, if you remember. But here you have, of course, also user interface. So when I was saying you have a REST interface and a SOAP interface, that's not all of it. Of course, you have a very nice AWS console where you then go to S3 and see the different buckets that you have available. There are lots of different configuration options for each or single bucket. And this is something where, of course, you also can think about that this is something you can share nicely, perhaps between different websites and so on. And of course, the key factor that you see a little bit in the graphic, it scales up if you need it for big data. Still, everything remains the same, the folders, the access via APIs, etc. So mostly this, however, used files with contents like websites and so on. Now, when you think about the prices, you see that here, it's also affordable in one respect. We talk here about a couple of, less than cents here, a couple of cents really for gigabytes. And of course, when you then go to the Glacier, which is sort of an archive service, and there's also deep archive service, the price seems to be in the moment, of course, relatively, low. Of course, think about also that once you put the data in, usually you want to keep it there for years. So of course, this will accumulate, right? We talk about storages per month cost here, which is good because it's not per hour, but still, of course, these costs can accumulate. And if you talk about big data sets, which we had in the beginning of the course, you remember petabytes we're talking about today, not gigabytes anymore. And when you have petabytes of data and you want to store them in basically an S3 bucket, there you go and pay again the prices. You can basically calculate that this getting quickly more expensive than this picture here is alluding to, especially if you keep it, of course, for years. Then, of course, we also have to think about that there's a certain idea of keeping the data there. So in other words, usually for some of these requests, when you use the SOAP API a lot, you would actually have to pay, and for others not. Usually would say the data inputs are not so much expensive, but when you want to extract data, then basically the retrieval gets expensive. So this is something which you basically have to think about. It's not only the storage itself, also the, let's say, the kind of costs that you have by using the SOAP APIs, by putting data, perhaps less, But when you get the data, then you have much more costs. And this is essentially now alluding to this REST that you see. REST is basically using the HTTP standard in terms of using these operations, get, post, put, and delete. And when you basically use this API, you see here also you have to have transfer in and transfer out prices, which then if you think about how often you use the API, could also, of course, accumulate to lots of requests, and then, of course, also to more and more money. It depends really how many users perhaps then use your app, and your app is always, let's say, getting the data out of the S3 bucket with a sort of API with REST, and there you go, you pay the price. Obviously, it scales with the number of users. That's nice, the interface, but still also you have to have more and more costs that you probably have to incorporate in your business model when you have this app. And this is something which you basically should also consider when you're basically developing applications, thinking about storing your data into the S3. Of course, in one respect, it's very safe, as we discussed. On another respect, it's also, you share it essentially with other geographical locations, like US, for instance, where you suddenly have your data in perhaps other let's say, countries where you also have other law. And this is all elements which you also have to consider using the S3 service, but I want to keep here the technical idea of this. So let's go a bit ahead with the types of storages you can have. Obviously, the S3 is a very simple service like of a bucket store, but you can have also volumes which basically are more or less something you already know from more file system oriented elements, this elastic block storage. Here we're talking about basically that you have just blocks and not any more objects. So here we have something which we can nicely connect to different, let's say, servers we want to run, and then have essentially a very powerful block storage. It would be saying that it's a bit like a hard drive. Of course, here we're talking again about virtualization. We talk about elastic block storage, which then has basically the files really in different blocks, and the blocks are then, for instance, then here and there replicated in order to ensure that when one maybe data center goes down, you basically have it somewhere else. Of course, you would connect this somewhere to an EC2 instance, because just having a block storage or having a bucket store alone obviously cannot compute. It's just storage. Hence, we have to combine this basically to attach this, so to speak, if you want, from the physical infrastructure perspective to a specific server. That could be an EC2 system, as I see here, that you maybe load, and which you basically then, of course, also have to pay, right? So this is another type of storage, hence there's another cost model to it, but still the pricing is, of course, something which you have to consider. But you need, let's say, storage also to a spinning disk here, or to this kind of different accelerators you want to have for deep learning. Of course, you need access to storage really to really compute and have the, let's say, results also stored. So these are two different services, and there's another one that you maybe put there, which is now really thinking about the traditional idea how you would do it, basically very file oriented. It's called elastic file system. Obviously, almost like a normal file system you would assume on your laptop. Again, you can mount it to different EC2 instances, of course, and that is, of course, something what you can you know, assume because you want to compute, of course, and then put the results maybe in the file system. The beauty, however, is that it's a shared file system. So you can have different EC2 instances running and basically connecting all to the same file system. So there's no need, let's say, to put your MP3 collection here and put your MP3 collection there. You can just share it between different elements when you want to compute on it. Or basically our upload download service might be another example, perhaps, of this. When you want to do some special elements, you know, basically using, for instance, deep learning with the images to categorize them maybe in the areas or types like, you know, Nordic lights or waterfalls or whatever. So all of this is quite nicely, and I have to say, from the user experience, really good. So when you want to connect all of these services, this is usually not really a big pain, as you would say, as an administrator. Here you can have really easy drop-down boxes. The storages you already configured is something you can choose from. And then, of course, it connects nicely to the different EC2 instances, so you can pick the systems you need. And this is something which really has a very good customer experience. So basically, it's that, you know, this is a system often needed, and this goes essentially for all the services that you see here, whether it's the object storages and the glaciers. S3, as I said, is sort of the de facto standard, but also basically of the Amazon Elastic block here and the EC2 instances you can put to it, or you basically have the file and then you connect this to different, let's say, EC2 instances running somewhere. All, let's say, different ideas how you deal with the storage and the data. And of course, underlying is the data transfer. Remember, in and out costs money, which is important here. Some examples here where basically you see the marketplace of Amazon also to be very important. There are pre-installed images from many, let's say, providers where you maybe have already, for instance, a MapReduce installation or Hadoop and Spark. And this is already, let's say, pre-configured with specific data sets, for instance, with specific software again. So you have here these different categories that you can go to the AWS marketplace to find much more, let's say, tuned instances, and basically I should say images and so on, that you then can put as an instance into Amazon, where you have lots of these basically available. And how you use this basically, and there are also user stories where you can basically obtain how people use it. This is something where you have, for instance, Airbnb, where you have essentially the need for scaling up and down again, depending on how many people really give basically their houses for, you know, renting. You would have lots of data to think about, but also data to analyze. So hence they use the Amazon Elastic MapReduce in this context. Of course, this load balancing, depending on how often Airbnb is used, you can imagine around or before just the major vacation times in summer, this is probably very much heavy use. So you need some elasticity in the EC2 instances. More people are using it. So this website should scale. And of course, has lots of data, perhaps of, you know, being free, being not free in terms of apartments. So the all management of this is quite complex to analyze when is the apartment free and all, of course, the other filters that you can do. So you see basically 5 GB of data daily. This is probably today much more, but you can basically do and assume there in Airbnb, given its more and more growing success, particularly also here in Iceland, we know the Airbnb apartments are quite popular. Another good example, I think, is the so-called startup company Spotify, which you today laugh about, right? When I say startup, and the same is probably true now for Airbnb. People laugh when I say startup, but of course they started small. It was an enterprise which could have failed. So nobody was sure that actually Airbnb is something where you would have suddenly some foreigner sitting in your own apartment or so would be successful, but it proved wrong. I mean, basically, everybody loved the idea, and suddenly you have a startup growing with the number of users exponentially. And then you need the infrastructure, the computing infrastructure that scales with it. And Spotify is just another good example. You get more and more licensed songs available that you're able to share with all your users. And Spotify, as many of you know, is very popular these days as well. And they store, for instance, a huge volume of all the different songs in Amazon S3. So 2 good examples how you basically scale up from a small startup, and hence there's an idea why they went to the cloud. And of course, also the economics of scale, again, getting the prices, creating an own Spotify data center might be not the best idea. So hence they use the Amazon infrastructure. And there are much more user stories, of course, at the AWS available. Another one that points a little bit into a different direction, and we will pick that up in lecture 13, is now also, of course, the IAAS solution that you rather do in-house. So here we think about the Volkswagen Group, you know, the manufacturer that is basically creating cars. So this is a topic which is a bit sensitive. So you would not to have your next design of the Volkswagen new Beetle or whatever coming up, basically somewhere in the, you know, whatever it is, what you do as a, you know, an electric car. this concepts, the designs, the idea, of course, something you don't want to really maybe necessarily put it directly into a public cloud. So hence they create their own clouds and use virtualized IT resources. Here, the motivation is just to spread the knowledge across different Volkswagen, engineers having a so-called private cloud. And of course, here and there using maybe still hyperscalers. So parts of it are also hybrid, but basically they create an in-house cloud. And basically, when you want to do an in-house cloud, one of the good ideas is to use OpenStack. Hence, we have a whole lecture about it, where you would say OpenStack provides you already with lots of pieces to create your own infrastructure as a service, and even more than that these days. And the interesting still is that when you really need to use a public cloud, there are good interfaces, as we learned with S3, where you can easily connect to, and also EC2, for instance. Hence, we can create easily hybrid clouds out of this, which we will also then, as I said, also look in lecture 13 and in other lectures again and again into. So this is another interesting idea how this is used as infrastructures. And another example here, also pointing a little bit to another direction, which is interesting perhaps here to show you how people using the idea of infrastructures. You see here that the NetApp infrastructure as a service application example has basically the idea of being a so-called honest broker, if you want, right? So you basically say, well, we provide you infrastructure as a service, but we can work and migrate easily with AWS, Google Clouds, Microsoft Azure, so that the migration is really, let's say, something where you can, shift your data and is so-called built on top of other infrastructure as a service cloud partners, basically. So this is a service that you can use, gives you added value here and there, and is basically something which helps you orchestrate your tools, orchestrate your services, and so on. And of course, if you think about that, of course, all of these have their unique selling proposition, right? So you can maybe pick different pieces from these different clouds. You have maybe the S3, basically to do your storage and do your interesting interface with REST, while in the Google Cloud Platform, you develop your app. So this is something, and of course, you can analyze it then, as you know already from the earlier parts of the course, in an MS Azure Spark cluster, maybe. And then this is something what you can, of course, consider. So you are not bound by one cloud forever, which is, of course, one of the selling propositions now of these, let's say, niche market vendors in this area that kind of work and interoperate with all the major clouds and provide then services on top that make that happening. So, and this is just two examples I just provided here from very different sectors. And of course, they are all, let's say, just very tiny examples. If you go to a huge Amazon marketplace, if you go to MS Azure, Google Cloud Platform, and on their websites, you see very different examples. But of course, a university course is not for copying websites. So I stop here and would refer you to this. And there you see how infrastructure as a service is really used by really, cutting edge, technologies, but also basically used by huge companies, enterprises around the world to make services you maybe already know and use, but you just don't know that the underlying infrastructure is really coming from AWS or MS Azure and so on, or maybe even from NetApp or from Iceland. What I now want to convey a little bit is the sort of idea of thinking, where does infrastructure as a service so basically end? And where does the more platform as a service, maybe even software as a service, is starting? And of course, we have to take into consideration why we want to do this. That's why I provided you here with an interesting example, which you face usually in companies. And you can always thinking about these 4 different models. And as you already learned about MapReduce, we're putting this whole into an Hadoop cluster, where the boss comes into your office and you're the IT expert, having, of course, heard my course here on cloud computing, perhaps heard also the HPC one and some others. You know very well what Hadoop is, you know very well what is MapReduce, but the boss will now say to you and say, should we go to the cloud or create our own data center? So now let's go to this exercise and think about what possibilities are there when you basically are tasked with this, right? So you can think about, of course, a bare metal on-premise, as we call it. That means creating your own data center, or perhaps just a cluster room, right? It doesn't have to be always a big data center, especially if you're a startup. But still, the point is it's on-premise. It's somewhere in a specific location that you have under complete control. You have your basically metal you buy, the racks you can put in, the compute, the storage, everything in this room. Now, this is something where we're starting to thinking about, okay, that's the bare metal. Now, what is a virtualized idea? When you think about specifically now the MapReduce idea, you can do MapReduce appliances, right? So that means you offer worker instances and images. You offer master images that you basically people then can use to create an appliance. So that is something where you go, this is already more virtualized. You could put this on a virtualized cluster to be used in your company. And still, that means it needs to be configured, right? So they have to work together. You have seen different workers. We need maybe 20 workers, and where the appliance then have to work together with all the different workers. So there's still some configuration to be done, and installations perhaps also. Then the next level, you would say, towards a full cloud experience would be then you just hosted MapReduce engine essentially within your company. You would say, basically, you would have the MapReduce engine always running. And this could be major costs. If you remember, if we run Spark and Hadoop constantly in the cloud, that means the EC2 instance underneath are also used all the time because you have a 24/7 MapReduce engine running. Hosting that yourself, right? Instead of going and moving towards the cloud completely by using a MapReduce as a service, perhaps as we have seen and actually used from MS Azure, for instance, with Spark instances, this could be much more cheaper. But of course, there you go. To do this MapReduce hosting yourself, or you let someone else host it, then you have to go and pay the price for it, right? And this is something we have to look a little bit through when we now go through this in the different categories of this deployment models. So MapReduce is obviously just one example of many. It could be any type of application. MapReduce has this interesting flavor of being, so to speak, a platform, right? So you basically can use it with different map and reduce implementations, as we have alluded to. It could be Mahout, it could be HBase. There's different ecosystems on top of Hadoop, which all have different map and reduce, classes implemented in order to solve different problems. So things which really then influence this kind of deployment model that we just discussed could be in many different directions. One is, of course, a price performance, which is, I think, most obvious. Data privacy is a very important one, often where you think about private versus public cloud. I always give the example of medical data sets. When you are a medical startup working together with a hospital and you have access to some data, you better make sure not directly move to public clouds. Otherwise, you're often in danger. Even if, the public clouds are relatively safe today, no one can really guarantee it. And if you have patient data somewhere in a public cloud, usually the hospitals that gave rise to this data are a little bit concerned. Data gravity. So you have to think about accumulating more and more data, right? The data is coming and growing. This creates certain gravity. So that means once you have the S3 service and your customer data and your image data and video data, essentially from all your Icelandic, nature somewhere inside the infrastructure, it's so-called locked. Before getting this terabytes maybe out again, it costs migrations, if you remember, in and out in a cloud costs. In usually not so much, but out much more. Data enrichment is another part where you basically have to think about, can you combine it with some different data sets? Can you combine it with different services? Productivity of data scientists. So basically think about that clouds here and there maybe have already some services you just put on top. And with this, you can basically have data scientists directly using these instead of having lots of administrators just enabling the infrastructure. And then basically, then you start with data scientists hiring. If you're a small startup, you have to carefully select the people you basically want to hire. Of course, often admins, developers are needed. I'm not saying anything against this. And I think there's a certain basically movement that even this is more and more needed again, because you basically have so many hardware to choose from and cloud services to choose from that you need these skills before you ever start with being a data scientist and using aspects. But these are the kind of influence, key parts that influence perhaps where you now basically and how you do your deployment when you, for instance, do a MapReduce cluster. But this means also more generally if you have applications, of course. So let us review the ones that I already introduced a little bit. So of course, you can put it in your own basement. One flooding, big problem, right? So certain risks go with it. We discussed this also a lot with, of course, now having bare metal means after 5 years, you maybe have to renew it. And lots of other factors where we basically, let's say, combine this as total cost of ownership. This is important because that's something also you have to think about, that there are many different factors to it. You need, on top of that, basically good people, right? Staff that really can do and, let's say, provide the infrastructure on a way that you can really put Hadoop on it. So what architecture you want to have, what CPUs you want to buy. You don't go downtown to a shop and actually buy a cluster. You want to know exactly how the architecture of such a system should look like. And you go to the vendors or to some, integrators, as we call them, that already talk to vendors. But still, it's a process that you need some learning curve actually to create clusters that then are also able to scale what you want with Hadoop. Then in the next layer where we said we want appliances, there it goes as well. You need experts that know about virtualization. Often you need also a virtualization tool. We talked about VMware as one example, but there are many others. But basically, we talk here about a more, shared infrastructure where maybe others want to use Spark and others want to use Hadoop, and would be usually the way how you would also set it up today. And this is, of course, something where, again, the learning curves is then even higher. You need people also on top of just knowing, the bare metal elements and about networking, security. You need also experts in virtualization, and there it goes also with the costs. So here we talk about more costs even. Of course, you get more service, so to speak, right? People in your company can use Hadoop services, can use Spark services, can scale that up and down. It's powerful. But of course, you go there and have to really, streamline all the different versions. These are open source versions that have to play with other open source versions in specific versions together. So it's a lot of work where administrators often use, automated scripts, but often they fail these automated scripts. So you need really people which have really experience in this. It's not just one click and then you have a Hadoop cluster. That's what I'm talking about. Then, of course, maybe you have a company that hosts it for you. So that could be an idea when you're not really an IT company, right? You have to think about this. Maybe it's better to team up with someone inside your country or maybe even in the hyperscalers that basically can host such a MapReduce engine for you. Of course, you cross the organizational boundary, which should be not forgotten. And this could be mean transfer of data, for instance, which is sensitive. So here we talk about sort of already going one step to the cloud where data is losing basically the gravity on your own organization. Data transfer costs. Is it possible to have my, let's say, 6 petabytes easily, transferred there? If you remember, MapReduce lives from the data locality. So also the storage is obviously then hosted by someone else. If that is sensitive data, you maybe don't want this. Still, it could be, of course, a very beautiful model of, let's say, not to have fund all the different administrators, which are said is basically good when you have a company specialized in this, right? There's specialized needs in storage and computing, as this picture here suggests. It's really usually an expertise of many that really can do very good Hadoop clusters. And that's what you basically should think about. If you're a small startup, it's probably much better to host MapReduce from someone else and using that. And then basically, there are lots of automation stuff that you already have seen in one of my earliest clusters examples here, where we were using some, Spark cluster very easily, which was hosted at MS Azure, which would be now then the next idea of thinking about that you just have this running instance there to basically have the deployment model D. You just use it from the cloud. The cloud obviously uses virtualization, has experts in the field. You have the pay-per-use model. You have no total cost of ownership. You can cancel it tomorrow, right? So in most of the cases, you can just say, okay, we don't swipe the credit card anymore. Maybe you have a monthly subscription, then you have to stop it next month. But this is something where, you still have your cluster in the cellar maybe, and you cannot just get rid of it. You cannot just sell it. Not everybody will basically want immediately a used server. So your ownership also matters. And that, on top of it, the software, think about the different versions. All of that is what you don't care anymore. You remember the MS Azure, where you can pick between different versions of Spark, and everything else will follow suit. Everything we basically had in lecture 5. But now we basically twisted it a little bit on how you basically can host MapReduce and which options you have to go through the cloud. And obviously, this is a model that many people have adopted. You see Amazon has one. We have already talked about the Elastic MapReduce service. And I think that's pretty clear if you think about it also in all the other services. Next time, we will look a little bit higher in this stacks, so platform as a service. But before we do this, have a sneak preview to the Borealis data centers. We're not going to Blöndos, which is this center here, but we basically will remain in Reykjavik and going to another Borealis data center. But still, I think this video captures a good idea, essentially, what these data centers are about. And of course, obviously selling the Icelandic unique selling proposition again with the location. All right, just a disclaimer, they're not paid by Borealis, but this is all I wanted to leave on the table for you today, and see you next time.